of finding electrons somewhere else. So we can determine this probable distance of the electrons from the nucleus of an atom. Call it orbital distance. So we say that the value of principal quantum number n of n measure the value of n measures the distance of electron from what? From the nucleus, of electrons from the nucleus to its energy level. What does it mean? The higher the value of n, the higher the distance. So we say that the higher the value of n, the greater the distance. Greater the distance of what? The distance of electron from the nucleus. What does it mean? Example, if the value of n is equal to 2, and also another principal quantum number is 4, right? So you say that the distance of electron in n is equal to 2 is less than the distance of electron in n is equal to 4. And this is true because I told you that these principal quantum numbers are different energy levels in one shell of an atom. What does it mean? Listen. This is suppose that you have fundamental knowledge of electron. This is nucleus of an atom. So nucleus of an atom. And this is electron. And this is nucleus of an atom. Here we have protons as a positive charge. This is negative charge. We have also neutron. So this we used to call it a shell. For example, let's suppose that this is hydrogen atom. This is the shell. So when the experiments has been done about the shell of an atom, then the chemists and physicists also found several energy levels. Okay, so they found several energy levels in the same shell. For example, Bose used it or described or used it to experiments on the valence shells of hydrogen atom, which is only one shell. So here we have the principal quantum number 1, principal quantum number 2, principal quantum number 3, principal quantum number 4, and then up to principal quantum number is equal to infinity. This is a nucleus. Suppose that remember that these energy levels are found in one shell of an atom, right? So this is the nucleus, just like at this point. So this ring structure. So we just use the straight lines because for the purpose of presentation. But this is the nucleus. Nucleus of an atom. So here you have, let's say, radius 1. Again, here you'll have against, let's say, from here to here, Here you have radius 1 plus radius 2, for instance, against here. So from here to here, this is radius 1 plus radius 2 plus radius 3. And then from this point to this point, again you have radius 1 plus radius 2 plus radius 3 plus radius 4. So that's why that we say the distance of the higher value of principal quantum number is higher compared to the distance of the lower quantum number. So however, that practically, remember that, practically, you will find that these energy levels, for example, this is the nucleus of an atom, so you find the first energy level with principal quantum number n is equal to 1, second energy level, which is principal quantum n is equal to 2, SEDI, and then so you'll find the SEDI energy level, which is equal to the principal quantum number n is equal to 3, and then so you'll find the fourth energy level is equal to principal quantum number n is equal to 4. So this is n is equal to 4, here we have n is equal to 3, here you have n is equal to 2, here you have n is equal to 1. So it is circular in structure, right? So that's the meanings of principal quantum number. So number one is specify the probable distance. So you see that we can know now the distance. If electrons will be in ground state, so it will be closer to the nucleus of an atom. And we have a strong nuclear attractive force. If electrons will be here, it will be far away from the nucleus of an atom. If electrons will be in this energy level, it will be again farthest compared to these electrons. And then etc., 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 etc. So that's what are one of the applications of the principal quantum number. Interesting. So I'd like to, in case you have any question, don't hesitate yourself to ask in the comment section. But that is all about the first applications of principal quantum number. So allow me to teach you the second application, where we find again another phenomena. We call it in chemistry screening effect. So to specify the energy of an electron, principal quantum number used it to specify the energy of what? Of an electron. And we have already discussed this in previous lectures or in previous sessions. So with this one, just I can teach you mathematically and then just return to the reasoning point because I've taught you. Because the second application to specify the energy of an electron. Okay? Energy of an electrons in the particular energy level. So we say that from, let me start from this, from the formula that I told you that, from the formula that the energy of electron is equal to negative 13.6 electron volt over n squared. You remember that? So from that formula, this is, the numerator is constant, but the energy of electrons is inversely proportional to the square of the principal quantum number. So from this expression that the higher the value of principal quantum number, then what will happen? The less the energy or the higher the energy. Because this is denominator. So when you have, let's say 4, so the energy is going to decrease. If we define in terms of 40, listen, if we define this formula in terms of positive value, then we say that if the principal quantum number increases, the energy is going to increase. Right? Increase. But now, in case that we have negative sign here, then we say that if the principal quantum number will be increasing, then the energy also is going to increase. It's going to increase. Right? So before I write that sentence, let me prove it for you. For example, let us find the energy of electrons when principal quantum number is equal to 1. So this will be negative 13.6 electron volt, and then here we have 1 square, so it will be negative 13.6 electron volt. Again, let us find the energy of electrons when the principal quantum number is equal to 2. So this will be what? Will be negative 13.6 electron volt, then you have 2 square. So simply that we have negative 13 over 4. This is equal to, means that 13 over 4 is equal to 3.2. So 3 times 4 is equal to 12. So 13 minus 12 remain 1. And if you add that once, you have 16. 16 over 4, this is 4 electron volt, but negative. So you see, the energy of electrons when n is equal to 1 is equal to negative 13.6 electron volt. And also the energy of electrons when the principal quantum number is equal to 2 is equal to negative 3.4 electron volt. Right? So if you compare, if you ignore the negative sign, then you find that this is higher than this one. But if you consider the negative sign, you find that this energy is greater than this one. So this one we found when n is equal to 2, it's equal to negative 3.4 electron volt, is higher than when n is equal to 1 is equal to negative 13.6 electron volt. So you see, so from this fact now, if you'll be computing that your homework now, compute when n is equal to 3, you will get, but you'll get negative 1 point something. So it means that now when the principal quantum number increases, then the energy of electrons also increases. The energy required to take electrons or to excite electrons will be increasing also. So we say that to specify the energy of an electron, so we say that we say the energy of electron in the higher principal, quantum number is the energy of electrons in the higher principal quantum number is higher than the energy of electron in the lower principal quantum number. So simply we say that energy of electron is then proportional to the principal quantum number. If you don't listen careful, instead of understanding, you'll get confusion. So again, after having that fact, we say that again we have another technology which we call the screening effect in this application. Screening effect, very important term. It has been asked in several past papers according when I've been reviewing them. So it's better for you to know what the meanings. What is screening effect? Say screening effect. So screening effect, from the terms screening in English, it has the same meaning like what we mean with the term of screening in in English. Say screening effect, we say that is an effect. So it's the effect. This is the effect whereby the nuclear attractive force, fails to reach to some shells or some orbitals. Have the meanings of what is screening effect. Screening effect is the effect whereby the nuclear attractive force fails to do what? To reach to what? To some shells or orbitals of what? Of an atom. So it means that it happens when a shell have several energy levels. When the electrons will be excited from the ground state to the higher energy level, to the highest energy level, then the nuclear attractive force fails to reach that electrons. Then we have screening effect. So for instance, that by using diagrams, these are the energy levels in hydrogen shell, right? So these are the several hydrogen, then as you see. So suppose that this is the nucleus of an atom. So here we have nucleus. So you find that this shell or this energy level of principal quantum number n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, etc. So you find that this energy level is strongly attracted, or the nuclear attractive force reaches successfully here, also it reaches successfully here, also it reaches successfully here, also it reaches successfully possibly here, but it's small. Then it's getting small and smaller and smaller, and finally you might find that the nuclear attractive force failed to reach this what? Principal quantum number or energy level. Let's say this is n is equal to 6, n is equal to 7. So the nuclear attractive force failed to reach this because of the distance, and then when electrons will be here, we say that that electrons is experiencing what is screening effect. So the failure of arriving, or failure of nuclear attractive force to reach into this higher energy level or higher orbital, that's process we got in chemistry screening effect. So that's what we call the screening effect. So it means that when we increase the energy levels, the energy of electrons in that orbital increases, but the nuclear attractive force decreases. Let me repeat. According to this second application, when we increase the energy levels, mean that we increase these energy levels, we go up in this way, right? From the principal quantum number n is equal to 1 up to n is equal to infinity. Then, so remember that here energy increases. But at the same time, when you consider the nuclear attractive force as we go up decreases. So we decrease what? The nuclear attractive force. So understand why? Because the distance from that energy level to the nucleus also has been increasing. Why the radius or the distance of the electrons increases. So you see that energy increases, radius of the atom increases, or of the orbit increases, but the force, the nuclear attractive force between the protons, or provided by the nucleus of an atom to the electrons, will be decreasing. So be careful. So let me teach you the third application of principal quantum number and end this lecture. Number 3, the principal quantum number is used to specify the stability of electron. The stability of electrons. So this used to specify the stability of an electron. So this used to specify the stability of an electron. How? So let me write this clearly. Of an electron. So the principal quantum number is used also to specify the stability of 40 of an electron. An electron's nanoorbital with a greater value of n is weakly held by the nuclear attractive force, making it easier for it to be removed from an atom, and hence that electron has higher energy and is unstable. We say that an electron found in an orbital. So this what we call them energy levels, or in chemistry we call them orbitals. So electrons in an orbital with higher energy level, it means higher principal quantum number, higher energy level, or principal quantum number, okay, is weakly held by the nuclear attractive force. Therefore, the electron in higher principal quantum number is unstable, and also is easily removed from an atom. Stable, so we have discussed about stability, and easily removed, means ionized, removed from an atom. So that the first and second sentence describing about the stability. So what does it mean? For example, that if you refer this figure, electrons found in ground state is highly stable and it's difficult to be removed from this nucleus or from the atom. Electrons found in this principal quantum number 7, n is equal to 7, is less stable and also is easily removed from the atom. So similarly, or we say that another phrase which is very important, we say that the electron found in lower energy level or in lower principal quantum number. Quantum number is highly stable. It's highly stable, and they strong, and strongly held by the nuclear attractive force. So then, that's how we use the concept of principal quantum number to explain the meaning of 40, to explain the applications of 40, or to explain the stability of electrons in its orbital or energy level. So now, let me leave the homework 11. Homework 11, okay? So homework 11, she say that briefly explain the second principal quantum number, explain the subsidiary or the angular quantum number. So explain that before we meet in the lecture or session or period 12. So make sure that you do your homework before we meet for that lecture. So this is the end of session or lecture or period 11. I would like to thank God for being with me since from the beginning, so for the preparation of this lecture, and even at the moment when I've been teaching you, and even during this time that we have been recordings. And I would like also to thank you for taking your time being with me in the beauty of quantum number. So may God bless you, and it's my prayer that you understand beyond of what I've been teaching you, because that is my intention. But just to find that you understand and even you can explain these concepts more than I taught you, or more than I know, because that achievements of the successful teacher. So I'd like to ask you that, or to remind you some few things before we end this lecture, in case that you want to get notifications of some other video or new videos that you are going to add into this channel, make sure that you subscribe, and also you share this material to your friends, to other students, so that they may enjoy the beauty of chemistry. And then, in case you have any questions about what I've been teaching you, or even about the general chemistry,